It works so well.
All right, we're going to do this thing. So welcome to Coffee Compiler Club. Here today, in theory, to talk about compilers, but maybe we're going to talk about, I don't know, Burning Man. I just got back, and language runtimes and typing systems and whatever other things. And everyone's recorded, and we show up on YouTube in a couple hours. I generally don't have a set agenda. I will say I went to Burning Man. I had a great time. I'm not a party person. This is my like 13th burn. I go there for doing crazy stuff and seeing crazy stuff. So I just showed a video of the Monaco, a very large art uh, car in the shape of a boat, a Spanish sailing galleon, diving in and out between dust devils. So the couple dust devils were circling around each other slowly, and this 30-foot long boat sailing the ancient playa is running around in between them. So it's very much fun. I had a lot of other fun videos, maybe not for this maybe not for Coffee Club, but it was good stuff. All right, that's it for my set. Does anyone have anything, or I'll leap into a random topic here?
I can ask a question about C compilers, but it might be big, so someone with a shorter question should go first.
No, you should go because this is the time for big questions.
Okay, so when I was writing Bold, the other week I mentioned that LSPs, you generally only need like 7 things, and I didn't really like the LSP format. Anyway, I was thinking about what if I wrote like a C parser to like deal with the headers, do jump to definition, and just do the stuff that I need for the LSPs. Then I realized that if I do it, I'm going to be extremely tempted to write a C compiler.
Right.
And I know a couple of people who've written C compilers. Don't think they're all here, but I'm very tempted. And I know when I wrote my C backend for Bolin, it took me like 3 weeks, but LLVM took me like 2 months maybe or more.
So what's
So I
the
was just
what
like,
what's the question or the observation here?
I was just wondering if I eventually I'm gonna have to do like my own version of the LSP, but I was just wondering if I end up doing a C backend, like a C code generator
Right.
for C compiler, how long is that going to take me, and am I going to hate myself?
I can't tell. Whether or not you hate yourself is up to you. That is 100% your call.
'Cause I figure I could stay away from like the bug information because since Bold is my IDE, I could just dump my own debug information and then use that since I control both the compiler and the debugger.
Having
But
stared at
codegen,
like people wrestle with dwarf for the longest time, and look at what Java does for debugging, having the code generator generate specialized debug info and then use like a DAP, a debugger access protocol, whatever, to talk to it, seems like a lot less grief than trying to squeeze whatever optimizations you're doing into whatever dwarf understands and that the IDE can show you with. I mean, this is like the Java experience, right? You have some code generator, it generates decent code, it generates debug info. The debug info is used to switch you to a second code generator strategy, second execution strategy, one that's slow and debuggable. And you can go back and forth between fast and slow and debuggable on, yeah, every 1,000 clock cycles, every 10,000 clock cycles. So at that point, you get like fast optimized code and perfect debugging, but you need to have somebody who can source the debug info in a way that makes sense and the ability to switch back and forth between fast and slow modes. And
since it's under my control, that'd probably be fine. I never actually made an assembly code gen,
oh, I
and
never did either. I did,
there
but I mean, I never make one.
didn't you like emit like raw x86?
I write a assembly-like thing in C or in Java, actually, in both. Right now, I have the Java one too. And it basically, you can write assembly kind of sort of like an assembler, except it's actually C code. And you put some macros down to give you shortcuts. And then the opcodes have parens after them, make a C call, which then dumps the actual bits into a buffer. But you write generic looking assembly code in C text the execution of that function throws the generated code into a buffer.
So this is
Exchange buffer.
open. There's this project called zydis or ZYDIS. It's supposed to be a
Like,
x86 assembler and deassembler.
yeah, the link is the easy one, and then we'll throw it in the doc. And I can even go link to the doc if it makes sense. See,
I'm
the
just
thing about
opening up.
writing your own assembler is when doing hotspot, we had to port to I personally ported like 5 or 6 unrelated CPUs and several variations of x86. And they all had to do the same kinds of things. They'll have to switch from fast mode to slow mode. They had to rewrite stacks. They had to put in read and write barriers, all these little assembly nuggets. They had to intercept low-level things like the fast version of mem copy. You had some generic inlining, whatever, but then when it got complicated and fancy, you went to some other mem copy which you hand rolled. Okay, so you have for every platform you write, you end up with a dozen, 2 dozen, 3 dozen code snippets that are 10 instructions to 100 instructions long, plus the interpreter itself, which was many thousands. They're all doing roughly the same things. So you write an assembly syntax, which is basically identical for ARM and x86 and MIPS and Itanium and everybody. It's just identical syntax. The registers are changed under the hood. The encoding is completely different, but you're still writing loads from memory, add, stack pointer, and offset. You're still writing, whatever, load, shift, scale, add to do a write barrier, that kind of thing. So you might as well write it in the same syntax and just have it be
Okay.
right.
I was nearly about to ask you why you wrote some kind of pseudo assembly,
Yeah.
but that answers it.
Yeah, that's the answer right there. I'm going to write it a dozen times for a dozen platforms. And it's going to be the same damn thing. So I'm going to write it, have it look the same way. That things that will actually change will be things you can't get from one architecture to another that you care about. Like the register numbers were all symbolic C names. And the register numbers obviously varied from platform to platform. And you chose which registers went for stack pointers versus function call or vtable lookups or whatever the hell thing you did. And x86 had addressing modes. That syntax got the one extra thing, which I can pass in an addressing mode other than reg or reg offset.
Okay.
Um, Most everything else, you just pick the same when all architectures have a load of a byte, a short, 16, 32, and 64 with zero and sign extension on them all, and all of them have a store of 1, 2, 4, and 8. You just have the same syntax for them all because that's everyone does the same thing.
So this is reminding me of how I did my debugging. I basically have a debugging layer where I execute commands, and then the debugging layer either use DAP or GDB to do
Right.
specific steps to implement whatever command I issued. Um, so did you also write the assembler, or is it, or did someone else do that and you just like focus on the higher part?
I'm sorry, did I
Like,
write the assembler? Yeah.
did you write the assembler, or did you just like stick to
Okay.
the pseudo assembler
Yeah,
you had
yeah,
and then
okay.
someone else
And Ryan, I
helped
see
you
your
out?
hand, so just a second. So yeah, so somebody else wrote the assembler. I thought that's a cool idea. So then I tidied up the instructions a little bit along with other people agreeing to whatever's going on. And I wrote the identical thing for MIPS, and I wrote the identical thing for Itanium, and I wrote the identical thing for Spark. So I didn't write the first one. Somebody else wrote the first one. I thought that was a cool idea. I copied the idea.
Okay.
But
Okay,
aren't
so
there
then I'll probably do the same thing that you just said, but with Zydis as my assembler, because I don't really want to look up a lot of assembly to figure that out.
Yeah, it's not terrible. The x86 is not terrible to assemble for once you get a few function calls to do mod, rm, sib, byte, shift, splatter, whatever. They're not, you need some function calls to do all the fiddly things, and they're not that big, and then it's done. So it's not terrible to write code for. I mean, to assemble for.
It's weird saying that I'm going to actually intentionally use a dependency, but when I was looking at the GitHub,
Right.
they're saying like they have 100% like code coverage and
Oh,
like
yeah.
all these
Yeah.
tests and
And
all
it
that.
didn't
I'm
have
like,
100% coverage because the compiler wasn't emitting some of these weird ass pack blah 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 vector inline whatever things. I don't know what, right? It was whatever the compiler emitted or what did I need to do to do outside language things. All the flip between fast and slow mode, that's all outside anybody's programming language. I'm editing the stack. So I need a bunch of instructions to edit the stack. Well, that's not no compiler admits those. I mean,
Yeah.
other than with intrinsics. So I had to head to those.
But
I don't go ahead.
I
Yeah.
was gonna say, aren't there some significant differences though, like between x86 and ARM? For example, the shift, it behaves similar in some cases, like in sort of the part that C and C++ call well-defined behavior. But
Yeah.
if I shift by a value that's in the so-called undefined behavior range,
Yeah.
the behavior on x86 and ARM is completely different. Like on
Yes.
x86, I think it does
Right.
like a bit mask, and then on ARM it does like
So
it
it's
just like
not, I'm not,
logically extends it.
so Ryan, I'm not writing an no undefined behavior assembler. Because it's not there's no language here. I'm writing assembly code to directly do things I can't get out of the C or the Java language. So the question about whether or not the shift is hits in the unspecified zone, oh, I don't write assembly that hits that shift into that unspecified zone on any architecture, unless I know that's what I'm doing specifically to go torture myself or something. But if I'm writing code to do a write barrier, it's going to be add the base of the page table to the address shifted by 9. Well, I want to write a shift by 9. That's well within the specified shift range for a 32 or 64-bit pointer. So I shift by 9. Okay.
Well, also, what about like there's plenty of instructions that don't exist on some architectures. Like I don't know if there's like count leading zeros in ARM or not, but
So count leading zeros is one that I don't write assembler for directly because I'm not using it typically when I'm implementing hotspot. In other times and places, of course, I've used count leading zero. The compiler will only emit it basically as part of an intrinsic, but the add intrinsic, he's not going through the assembler path. He's actually just spitting bits into a buffer. So the assembler is to help me write large scale chunks of assembly, maintain and manage them. Like I'm doing an inline cache, which is a state machine. There are like three instructions. I have to patch the offset, the expected class, have to have a fail out branch. So I'm patching three or four places. It has to not span a cache line so I can get an atomic update. So I need the assembler-ish thing to force no ops to do the padding so I don't span a cache line to carefully align the offsets of the different pieces and give me references to them, which is all like a little junky pieces of C code, and I'm writing little tiny bits of assembly snippet that are patching pieces. Okay.
wait, are
All
you
I'm saying here is I'm not doing the entire x86 architecture. I'm just doing these sets of things.
That sounds really hard because don't you have to like flush the pseudo assembly before you emit the intrinsic?
Okay, so there's code generation separately. So I'm writing the code out as an assembly because I want to think in my head, this is the state machine I'm trying to implement. It has the following steps. It's going to patch instructions, whatever. I write this assembly code. That went into a buffer. Somewhere else in the universe, I said, go install this code, and it gets hit when the runtime decides it needs to patch an inline cache or whatever piece it's going on. It's doing slow path GC or whatever. So that code then gets installed, meaning that it probably moved from some temporary buffer where it was a double resizing thing to I got whatever. I moved it to a code cache, which is a known 4 GB set aside virtual memory space that is going to get TLB mapped with one TLB entry, and I have read and write privileges on, and then I go say, give me write the stuff, take away write, put execute back on, flush the iCache. Those steps are all done as part of injecting assembly into the running process. Whether they're done by C2, which doesn't use the assembler, just spits bytes into a buffer. Somehow I got bytes in a buffer. There's an injection path. That's separate from, I'm going to write several hundred lines of assembly code. That's enough that I want to have some reasonable support from something that does things that an assembler normally doesn't do. Also, I want to write it 17 times over for 17 architectures, five times over for five architectures. It's almost identical every one, but not quite. And it's
Would you
no C
change
thing. You can't do it in C. That's the whole point of that's why I'm writing assembly. I can't get it done in C.
would you change anything? Because that sounds annoying to me, but I don't know.
Well, I need to do something. I want to go from fast to slow and back to fast. So I have some switch between fast mode and slow mode. And slow mode is an interpreter, which, by the way, is a giant handwritten assembly because handwritten assemblers are, sorry, or interpreters are typically much faster than any of the things you can get out of C code interpreters. They do things with the dispatch loop that you can't get out of a C dispatch, and that's the key piece for that. But I'm writing some big chunk of assembly code. I want some support for that. If I'm not writing assembly code, I don't care. I'll go write intrinsics in whatever language, GCC with the built-in assembler, and I'll walk away from it. That's the path if I have 1 to 10 ops. I got several thousand ops I'm writing. Maybe actually for hotspot, a port of hotspot is probably 10,000, of which five is the interpreter. I want some more support. So move away from the standard assemblers. Don't give me that support. I write my own assembler because it's less total code and effort than it is to try and wedge in somebody else's assembler doing a job that it's not designed to do. Another way to think about it is I write a DSL, right? A domain-specific language for writing interop of C and generated code and an interpreter where things are not, they're outside the C language spec to do that. Just all GCs go rewrite all your pointers. Where'd all the pointers come from? Well, you crawl the stack and ask all these questions. All that stack crawl, find things. None of that's ever in any language, well, any C-like language spec. Yeah, there you go.
I think
Matt
Livo
has
was
a thing
asking.
here.
I think Livo was asking primarily how you do machine code emission for the code gen, and you don't necessarily need an
Oh,
actual assembler for that. You can just do the
no, I don't.
encoding.
C2
Or
emits
You
code.
can
I'm
also
sorry,
take
that's
a
a
look,
different question.
Livo, you can also take a look at this Asmjit video. Despite the name, it's not just for just in time, but it starts with the just in time as the example. The nice thing about it is that it supports both x86 and ARM64 in one
I
place.
won't get into it now, but I am more interested in JITs lately. That's a whole different topic, though.
Then that's it may be good too. It's pretty simple and actually has interesting things, like it actually has a layer called compiler that even allows you to do register allocation, which is not that common.
So the hand rolled assembler I do would, because it's written actually in C, would do some amount of register allocation. Not, you would specify the registers and it would tell you that you had no conflicts was the usual way it went. So you hand assembled, okay, you did, but you didn't, you got an assertion that you didn't screw up and clobber a register that was being held reserved for whatever base of the thread allocation area or whatever.
That's the other thing. If I was going to be tempted into writing a C compiler, the rest allocator would be reducing that temptation. I don't need a rester allocator if I'm just using debug mode, right?
And you need a register allocator, but it can be a really simple one.
Because
It,
I just figured that you probably don't need more than like a few resters for any given syntax, and then for function calls, that's like the only time where you might need to do like 8 resters because it
whatever the
takes
arguments
eight
are.
the
Well, the
ABI.
How
usual,
much code is a basic linear allocator?
right. It's not a basic one is not a lot of code, and it's going to do a lot better than fixed register choices, which is what you just described. The
Uh,
next step up from like truly tiny fixed is like I do nested expressions. You grab whatever the Sethi Ullman, whatever Red Dragon book pattern for doing that, which works until your expressions get large enough that you run out of registers, and then you're still off in the land of I'm spilling now. There's definitely a thing there where you want to do something with registers. You can get away with the super trivial, and you'll have really bad code. A linear
or the
scan is
debug
not
mode.
that huge. And then Simple has a graph coloring one that you can take a look at. It's not that huge either.
Oh yeah, I should. I should.
It's not super awesome. It's,
Did
it's actually decent. It's not super super, but it's decent.
did Yasser ever post the graph coloring example that he mentioned the other week?
Ask Yasser. I don't
Yeah,
know. He
I should.
posted some examples, so I don't know. So did you get your question? Matt said your question was really how do I
Oh,
emit code in the JIT in bulk, which is not with hand roll assembly. I don't go through.
Well, my question was more like because it sounded to get the your your DSL into the byte buffer, it sounded like you had to remember to flush, and then you emit instructions directly. So to me, it sounded like it'd be annoying to remember to flush every time, or
Oh,
to
you don't. No, no, no. You don't
no, no,
flush
but
every
you answered
time.
it. But I mean, when I asked the question, I thought it would be just to be annoying to do it that way. But then
Oh,
when you started
no,
explaining
there's
it, I'm like,
no.
okay, it's not as what I thought.
Okay. Yeah, there's no
Yeah,
flush
sure.
as a thing that you think about. You open a curly and say, put an instance of the macro assembler as a constructor. On destruction, he will do install, flush, icache things. Then you just write your assembly, open curly, say, make me a macro assembler object. Write my assembly where I'm saying, macro dot load dot add whatever, except I get rid of the macro dot with a C macro. So it's just like under space load for of racks comma blah 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 under store for of RCX comma racks whatever. You write your assembly. At the end when the close curly comes, code's jammed into a buffer, icache is flushed, it's all ready to go.
No, you answered it.
Okay. When I'm doing C2 generated, C2 doesn't go through an assembler step of any kind. He has as part of the machine description the encodings. And so when he's done and he's running through things, he just runs the encodings he's got and slams the bits into a buffer. And then he goes to the same thing that the macro assembler does. It says move to the code cache, flush your icache, blah blah blah, install things, whatever it's going to do. Okay. And Ryan, you were going to talk about something too. Bit
Hmm?
choices.
Yeah. So I could just give an update on, I guess, what I've been working on my compiler, and then um, kind of some ideas for bitwise operators that I've been having to make it easier for new programmers. I don't know if that's in the scope of.
Yeah, certainly. Language design is in the scope. You want to share something?
Absolutely.
Sure. Let's see.
Absolutely in scope.
Yeah.
Ryan, I have a question for you, but maybe I should. I can ask it now, but you don't have to answer it until like later if you don't want to.
Go ahead and ask.
Did you end up looking at my language because it's? I got a question about that.
Was yours the? I think I took a quick look at it. I didn't look
Okay,
too deep into
so
it.
one of the things I did for beginners to easily understand the language was I try to make it really high leveled. So I don't know if when you're saying you want to make this easy for programmers just to learn, I was wondering how high level did you try to making it?
Oh, this is a very, very low level language. So obviously, it's easier to learn a higher level language, but also I would like to make low level languages a little easier to learn. So these are some of the ideas, but let me just kind of uh, talk about what I've been sort of working on here first, and then I'll go into some of the bitwise and the philosophy stuff afterwards. Let's see if this runs here. Nope. What did I do? It
Yes, live
I broke
demos.
it. No, no. Expected type symbol. Okay. Yeah, I need to just comment out this function I was working on. Uh,
I've never seen your language before. Can someone tell me why there's a var like a colon equals and another line that does not have var and colon equals?
so this is the assignment operator. So this is just creating a new variable. And
And then
then
the so what's the difference between just equals and colon equal?
you can't use equals.
Oh,
That's not a valid assignment.
The
That's
language design choice to prevent you from accidentally confusing assignment with a quality test.
yes.
Yeah.
So one equals
interesting.
never valid. So let's see if that fixes everything. Okay. There we go. Okay. So what I've been working on, one of the things that I've been kind of uh I guess I could talk a little bit about the compiler design because I'm trying to work on like basically string content constants right now. So one of the things that I've had in this language is like you can see like literals here. And these don't have a type. So like in the sense that in C++, if I put a literal that like creates a 32-bit value or whatever, in this language, similar to Go, literals don't have a type. They're just like typeless values of some sort, right? Um, and so one of the way that this works is that there's basically when I'm generating code, there's something called a gen value. And these gen values are like they could be like a reference to a like a local, which is like something basically like on the stack, but maybe it's not on the stack. It could be in a register that gets optimized later. Or it could be a literal, or it could be a binding. So binding could be like I'm calling a function or something like that. And so that can generate a binding. And so it could be either a local, it could be a literal, or it could be a binding. Um, and so these like literals, so what it'll do when I like generate an operator. So let me go to my code.
Well, go. I mean, you're heading into a fine-grained description of how the compiler is designed, but that's not going to come across very well. I'm looking at your language design choices, like equals versus colon equals, and you did something with shifts that.
Oh yeah, I was going to talk about that after. I just kind of like I wanted to talk about specifically this like concept of first I wanted to like this idea of like string constant and how I'm working on that.
And how it
Because
doesn't look like COBOL in the slightest.
I don't know, I don't really use COBOL. Uh,
It's the all caps thing.
well,
Yeah,
okay,
So
I was
the
wondering if caps meant anything.
the
yes,
dot value means it's a field in a class, and if for and the basically the thing below is the function means it's just a parameter of a function or something,
so
or a
actually,
local inside a function.
I could talk about the uppercase thing. So anything that's a keyword is uppercase, and if it's lowercase, it's an identifier that's not a keyword. So usually, like the idea here is that if I write a function that the compiler is going to give special behavior, it's a keyword identifier because the compiler is going to treat that function special in some way and do something special with it. So therefore, I need to use a keyword name. So like this is still like this because it's a treated specially as a keyword, but like normally you would like name a field as, you know, an identifier, but certain things are like keyword identifiers. And that's so like this is dot x, it's a variable. You could have like dot f and then
Okay,
like
so
a function.
it's just a name after the dot in that case.
Yes. But
All
if
right.
the name has special behavior, then it's a keyword identifier, and all the keywords are uppercase. So
And the dot is basically saying I start defining a new member now or something.
right. So it could either
So
be dot or it could be like this. So this is like static or um
so basically every member definition starts either with a dot or two colons and ends with a semicolon.
well the functions don't have to end with a
Or
semicolon.
like curly braces. Yeah, okay. Understood. Okay, thanks.
Yeah. So the philosophy here is just that I want to be able to add new keywords without conflicting with any existing code. And
Uh,
so
this is related, but I used to have my on statements be start with an underscore and a capital letter, and that would be just an easy way to say everything that's underscore capital letter is reserved. Everyone hated it. I was so surprised of how many people told me they hated that syntax. I eventually just changed underscore o n as just on, just like the lowercase o n. Like
Right.
I don't know why people hate it so much, but you might get some of that later when you switch to
maybe
I
people will
mean,
hate it, but I
I,
just
yeah.
I mean the core distinction between the various approaches is whether like the dot and the colon is at the definition side only or also at the call side. I mean, you have like most languages have like these hints only at the definition side, but for instance, I think JavaScript classes have like the bang, the hash at both the definition and the call side. And I guess it depends on how you imagine or how you want to have your call side look like, whether people are going to
So there is a
object to
difference.
it.
So if I I can actually show probably some case where that's used. Maybe. So like when I'm using colon colon, I don't need to put colon colon. So like these are all declared as like sub symbols of the file or the global namespace in the module. So they don't actually require this colon colon syntax.
But
But like if I did like um
I see what you're doing there. That's clever because you're basically saying the way I go through namespaces or how I access a field or function of my value is basically the same way I would write it at the definition side, right?
no, so like here's an example where I've created a namespace, right? And then I create a function inside that. So in this case, I could access this like HUF buzz like that.
Yeah,
So
exactly. Yeah.
similar to C++
Clever.
in that regard. You wouldn't be able to do like huff dot buzz because this is a sub symbol. It's not a member.
Yeah, that's very clever.
So yeah. That would be how you would access that. Um, and then when you access a member of like if I am in a class, I can't just say I want X. I have to say dot X. So instead of being this dot X or just X, you have to do dot X. Or you can do this dot X if you really want to. You can write this dot X, but dot X is like the preferred way that you would access it. Um, and that's
And
for memory.
also from the outside, right? If you have a value of class spam, you would access the X with like dot X.
Yes. So let me see if I
Okay.
can find where that's used real quick. Yeah. So b dot x equals
Hmm.
5. B dot y equals the little address of I. Um, so yeah. So it's similar to C++ in most of this, except the syntax for a member function, instead of saying static if I want it to be like not a member and just leaving it off if I want it to be a member, I just put a dot if I want it to be a member, and then if I want it to be a non-member, it would be like
Yeah.
this is static uh function, function.
I mean, I personally would probably object to having operators for this, but I have to say it's I really like it because it's really innovative and it's not like the old boring we are slapping a static modifier in front of it and I mean it's like it's connecting how we are calling it to how we're defining it, and that's pretty cool. I haven't seen that before.
Yeah, so that's kind of the way I'm separating like static variables. So we could also make like static variables, like if you wanted to do z var i32. Now these don't work yet, but they will work in the future. So I haven't actually coded this part. Global like variables don't exist currently, um, but they will later on. So, in
Go
principle,
find go find
in,
your bit operators.
oh yeah, okay. So let me before I go to the bit operators, let me go over the constant idea here of so where I'm getting at here is like when I like do an assignment like this, what is happening is it's creating a so we're calling this like I32 assignment operator that takes an I32 as a parameter, right? And that's going to be like operator colon equals uh something like this, right? So it found this operator here, which is like other. So this is what it was trying to look up because it got a numeric literal and it's got a reference to itself as this parameter. That should probably be the first. I need to like make it not do this alphabetically because this should kind of be before other. But So it's got this overload here, which takes like the itself as a write reference, so it does a little reference conversion, and then it's got this I64. So what it's then going to do is it's going to try and initialize the somewhere old constructor for I32, and it's going to look for this sort of numeric literal. So it's going to try and initialize the I64 constructor, and it's going to look at these candidates. So that's like the function overloading, and then it finds this one. And this is actually like special. So there are what are like called intrinsic functions. So if I look for load const int here, so like certain intrinsic instructions exist, and what it's basically doing is it's looking when it generates the instruction, it's looking if it matches this like intrinsic. Wait, hang on. Is this?
But is there a reason why your overloads have the other parameter before this parameter?
Yes. And that's because like conversions use the other parameter as well as like a default copy or constructor. So it's not a positional parameter, it's a named parameter called other. And this is like if I have a class that maybe can accept positional parameters for some reason, like I don't know, it's like an array. I want to separate potentially the copy constructor from the like array constructor that takes one positional parameter or something like that.
So,
Maybe.
so walking me through this. So you have like an integer literal, and that's causing the second candidate to be selected. So what's the value of, I guess the value of numeric literal is like your integer literal, but what's the value of this new reference, I guess? It's to be initialized.
Right. So this is actually a slot. It's uses the same syntax as references, but
Oh.
one of the things that the compiler kind of does is it keeps track of like lifetime scope when you do function calls. So like function calls have like an implied effect on the lifetime of their like arguments. And so if it's a new slot, then that like writes out a result to that slot. So like if I look for return, let me see. Uh, do we have at return somewhere? Okay. So like the actual implementation of a return value is the new slot where the parameter is named return. And this is going to be like optimized in the code generation to like you be like an actual return through the return register if the type fits in the register and it's relocatable, or it could go through a pointer if it's not. That's a whole topic by itself, whether or not you can use like the actual return value as the or if you have to take a pointer. Because like in C++, when I call the constructor or like when I return something, like sometimes I have to like allocate storage and then pass a pointer to the storage to the function in the ABI, because the constructor can take its own address and do stuff with it. So may not be able to like pass it by value, I guess. But that's kind of a calling convention issue. For the actual code gen, it's a slot like this. And so that's kind of a named argument. So it's just a like an argument that writes a value out instead of accepts one. Probably by like a pointer as the implementation, but it could also be a like return at the sort of assembly syntax as well, depending on the optimization. And it would prioritize the one that's named return for that treatment if there is one. Otherwise, maybe it'll pick a different one. But that's later. Uh, so anyway, I guess like when I construct this call, I'm looking for this invocation arguments, right? And it's checking if the arguments are the codegen literal, right? So I've got this literal and I'm constructing I'm calling the where did we go? I64 dot constructor with the, so I'm calling this numeric literal. It detects that, and then it creates this instruction, and then it pushes out the instruction. So there are certain like function calls that are treated as intrinsic instructions, which actually generate the actual instructions for the machine. But they go through all the like the overload resolution and all the machinery to like resolve them. And then it at the end it just checks this intrinsic instruction to see if it's like should be like an assembly instruction, basically. Not quite assembly because it's an intermediate representation, but it does that first. And then it converts it to this like load const int, which is a like primitive operation on the locals. And there's similar ones, like if I'm like load constructing a reference, it uses this load from reference instruction. And then like there's the default constructor here, which is load constant 0. And then like we have store to reference and other different like intrinsic instructions like dereference pointer. So it all goes through that like operator overloading. Yeah.
Because I'm still waiting to see
Okay.
shift operators.
Okay, hang on. Let me speed up here a bit. Okay. So one of the problems that I had with this though is that in order to because literals are not actually objects. So one of the problems that I ended up with doing all of this is that you can't like have a user defined type use a literal because they're not objects that can be passed into a function. They only can be used to sort of call these like generator intrinsic functions, right? Because they're not actual objects. So what I've instead of having the string literal, I've created this concept of like a string constant. And the idea here is that this is basically something that can be constructed with a literal that points to some data in the constant section of the program. And then the idea here, which is not 100% there yet, but if I go to the Roman class, so this is still kind of in progress here, but the idea is that you'd be able to get a pointer to some constant data by taking the string constants dot begin and end functions, and then you can like iterate over the data inside the constant and then do whatever you want with it. Similar to how you would so like you actually just get the literals data as it was like typed into the program, and then you can construct your object based on that. So you can have your own like user defined string type. That's kind of the idea. Yeah. So that's a work in progress. But
Yeah. Okay.
all right, bitwise operators now. So let me see operator syntax. So I have so here's the logical operators first, right? So I've added some new logical operators like we have and or, but I also created like these other operators that we have in the logical comparisons like and inverse. So there's like an operator NAND and there's operator NOR. There's an operator exclusive OR. And then we have like A implies B, B implies A, and then there's also this sort of suffix. And then for bitwise, for the first part, it's the same, except I'm sticking a hash in front of them. So for example, it's hash and. So you can always know what the bitwise operator is from a logical operator by just adding a hash to it in the front, and it will be the same. But where I guess the possibly controversial idea here, and this is bothered me because when I'm thinking of like a sequence of data, right? If I'm thinking of an array of data, the way that I've mentally visualized this is like I'd write, here's my bytes. I don't know, var array equals, whatever. Like it looks like this, right? 1, 2, 5, 7 or something. So these go like from left to right, but then somehow and I'm in little endian, right? It's like 0x00, 0x, 0, or let's say 0, 1. But like if I want to push a bit from here to here, I'm shifting left, and then it ends up like if this is like FF, right? Like this, and then I shift left, I'm somehow like I don't know, like
Whoa.
F, what is the next one? I don't know.
You shifting right, you concatenating two bytes and then shifting them right
If
or left.
the but like it ends up looking like this, right? So like I've shifted left, but now somehow something that I see on the right is now
This
um
is because you're writing them in byte order as opposed to thinking of them as a little Indian pair of
right. So
letters.
anyway, my thought was like the whole endian thing, like shift left and shift right only makes sense if you only use big endian, right? If you use little endian, it doesn't make sense.
Okay, wait. Indian is a form in memory. If you load it into a register, this problem goes away.
That's true. But anyway, but we have to work with this and
No,
I
no, we
often
don't. The obvious semantics are load the 16 bits into a register, shift, store them back. Whether the load and the store do big or little Indian shifty games is up to the load and store about how they're representing things in
right.
memory. But once you're
It
in register
it
and you're
does make it
shifting,
hard to reason about though. If you're thinking about depending on like when you're doing encodings, right? So anyway, my thought
But
here.
that's a fight you're picking for yourself. Yeah,
yeah,
like you don't have to pick that fight if you
yeah,
don't like, right?
So
right.
here's my perspective. Instead, I'm shifting the value up or shifting it down.
Yeah, but get little Indian or big Indian out of the equation, and then the shift is fine. Whatever. I mean, that's not what I'm going to use
I
for a
mean,
syntax, but I don't care.
yeah, you can have a look at it that way and
For
doing
left.
the plus plus and the minus minus for up and down is, I guess, you can do that. I mean, I would, of course, object to the number of operators in principle, but
Yeah. Yeah.
looks good for me apart from that.
So like the idea here is like instead of conceptualizing this as left and right, because that's endian specific, I'm thinking of this as like shift up for make it bigger and shift down for make it smaller. And now you no longer have this problem of like which endian am I using? Am I going from like
Well,
this?
I think you're making a problem for yourself because no one I know of worries about which Indianness they're using unless they're really into network byte buffery code, things that are just doing, I'm computing a pseudo random number generator. They don't care what Indianness.
Oh,
I've run into this a
um,
lot when doing cryptography where it's very confusing. Um, Especially when you have to work with a value that is larger than fits in your registers or like your native type, and you have to write
Yeah.
bigger integers.
Yeah, now you're into networking land. So yeah, okay. That sounds like a very niche case to design your language around, but you do you.
Well,
I
also
mean,
as a new
uh,
programmer, it does feel like left and right are just confusing.
mm, yeah, I mean, as a person who would never use these operators, but I have methods or functions for shifting, and they are called shift left and shift right. And looking at that idea, I'm really thinking whether shifting up and shifting down wouldn't be, I'm not sure. I mean, for people who are experienced with
Ryan, you have
programming,
echo.
for the,
Would you
sorry?
Ryan, would you mute while Simon's talking? I think we're getting echo from you. All right,
Ah,
go
well,
go Simon. Yeah.
I mean, for experienced programmers, I think understanding shift up, shift down um, is not an issue. They will probably say, well, that's weird, but I understand what it does. And for people learning it, shift up, shift down might be more intuitive by 0.5% or something than shift left, shift right. Um, I mean, it's basically the same for like rounding, right? If you round numbers, you also say round up and round down and not round left and round right. So
The rounding says up
interesting.
and down specifically.
Yeah, exactly. Yeah, that's what I'm saying. It's like we're doing the same for rounding already, and I mean doing the same for
All right.
shifting.
You're saying the
I
up
mean
and the
that
down are kind of sensible because it does make a larger or smaller value. which,
Um,
okay, yeah, I can buy that.
I mean that the other question is like if you're not doing the operators, but we're doing like the functions with names, whether shift is the right word for it instead
Yeah.
of shift left, shift right, like push up, push down or something. I'm not sure if you if
There's a funny history,
right.
right? These were the super cheap things you could implement in silicon. So everyone had them since the dawn of time. Then you had them and they were cheap, so you used them. So now we're having a higher level thing. We'd like to like consider like the number of times that I actually need a bit rotate, I can count on, one finger in my life. Um, and the compiler will totally synthesize a rotate if I do a pair of shifts with an OR operator or the correct ands and ORs. The compiler just synthesize it. So I don't ever think about rotate. I wouldn't have that. When you say too many operators, yeah, I would say don't bother with rotate. But otherwise, these collection, these operators, why do we use them in daily things for anything? I want to have access to them. I have a handful of times I use them, but it's not a driving concern for what I would do with a language, right? I mean, when are you using shift up in your writing whatever code you're doing? You're not doing matrix math with shifts. The compiler will do that, but you're not writing that. I mean, I'm not saying you're not, but it seems unlikely. I don't know.
I feel like I use these anytime I'm doing any kind of cryptography or anything like that, or like file operations where I'm encoding something on the network or crypto. Yeah, so
Yeah,
there's
you're encoding.
definitely.
So
But that's a very, very small
yeah,
percentage of
yeah,
code that's ever being written. And I mean, if that's like the use case for your language, then it might make sense, absolutely. But
right. That's where I'm at. That's not my
it's like
normal daily use
it's
case.
like if you have like your standard language that's shuffling data from some JSON format A to some JSON format B that's slightly different and does some HTTP in between, then I mean you don't care whether your shifts your bit operations have nice operators or not.
I have a
And that's
unrelated
basically and
topic.
that's like the like 90% of like the line of business code that gets written these days, I guess.
I think hash functions may be fairly common. You often have to do hashing, and not just for hash tables, but even if you want to distribute something
Yeah, I use hash
among
functions.
different nodes, networking
Using them
code.
is common. Is writing them common?
No, I'm writing them. Well, yes, for me. You could argue that I'm uncommon.
You mean we should have an operator for hash code or something?
No, I'm saying that the right, using shift operators like up shift, left shift, or left or whatever, that's common because you commonly write hash functions.
Ah, all
I
right.
would be willing to require a pound include to pick up um, shift operators when I'm writing a hash function. Like the number of times I write hash functions, it's definitely there, but it's not super common. So if I need to pound include bit operators somewhere, yeah, Ryan, you get feedback again.
Um,
Um, yeah, I would totally suffer that penalty in exchange for taking all those operators out of the core language because outside of like hash and some crypto-y things, I'm not doing bit mashing.
well, I don't know that
In your language, can you import just an operator?
no,
So the type is already there, but you're just importing an operator that takes a type on the left and a type on the right.
no, you can't do that. So the operators are built into the language.
You know what? Since you are using hash already to indicate that there is something special going on, like a shift, I would actually consider spelling this out like SHL for shift left, SHR
Yeah,
for shift right, and shift arithmetic right with SAR. Because you're probably gonna still need the distinction between the arithmetic and logical shift, because you still may want to have the sign extension or not as a programmer. But if you just use the mnemonics for this, I think it's easier to guess what it means, even than easier than plus plus or minus minus.
Mm-hmm. Mm-hmm. I'm gonna switch to the docs here, and then write some. Oh, look at this, all kinds of stuff. We have a blank, yeah, down here. Yeah.
Yeah, exactly. I think the version that just uses the mnemonic is really
Mm.
unambiguous.
And so on. Yeah.
So these may be changed a little bit. Like this part, I'm not 100% sure. So this is like, okay, I have a pointer and I want to get its value, but if the pointer is a null pointer, then I just get whatever the default value of that type is. And then this is
Mm.
kind of the same thing, except it gets the address of a field in a type if the pointer that it's operating on
Are
is
you
not.
pointing at something that we can't see? Should I go back to?
Can you see? Come on.
I'm on the Google Docs because I was typing alternative with pound syntax.
Yeah, on Ryan's
He should be able to
screen.
share again. Let me
I mean,
stop
I,
sharing.
I, I guess the question mark greater than is basically
Hmm.
no, I thought it was like the question mark in other languages, but getting the default is different. So that doesn't have like a second operand, right?
Doesn't Kotlin have a default get value or default? Somebody
Um,
does.
I mean, most have like this question mark, where you specify the default value inline.
Hmm.
I think the question mark greater than from Ryan doesn't have a second operand, but it takes the default value from the type definition or
That's
something.
actually a good idea. So maybe I should add like question equals. So like get value or evaluate alternative expression operator.
Well,
Okay.
that's
So,
question mark colon,
but
right?
then what? Yeah, but what does the question mark do then?
So this is like so in this language, like I can't do if pointer because
Mm,
a pointer is not a
all right.
boolean.
Yeah.
So this is not allowed. This is a compiler error. So if you
Yeah,
want to
because
say
my
this is
favorite language hack is
Uh,
everybody can be considered a Boolean.
Basically like a Boolean, a cast to Boolean thing. Mm,
basically, yeah.
Yeah.
okay.
It's not the same because like a pointer is not implicitly convertible to a Boolean. So you have to call this operator.
Yeah. That's
Yeah.
what,
Well,
yeah.
okay. Okay. And the get field address if non-null operator, how do you imagine how would it look like in
Okay.
code?
So
Like
that's like
what's the
so let's say okay, C++ version here. Um so this would be get field address if not null, and then so I have, I don't know, say a template. I'd name P. Actually, I can't do this in C++ very easily. So basically what this does, okay,
just write the pseudocode in your
pointer,
language and would you
and then so and that would be foo. So what this means is let's say that I have first
so it's like a navigation
If it's null, you get a null. If
operation.
it's not null, you get address of foo. Pointer plus.
so I start, let's say I have F, which is a pointer to foo, right? And then I do this, and let's say that class what is that, what I do, foo class, right? And then I have dot B is a bar, right? Okay. And then so I could say
Completely
var.
unrelated, sorry. Completely unrelated question. Why is the class in this position written after the identifier But if you're writing a function, it's written before the identifier.
Oh, it's actually written first. So it's always name, what it is, but only inside of a
If you
function.
do dot constructor, like this dot constructor is like the magic identifier name.
Yeah.
Oh, sorry. Okay, apologies then. Then I understood it. Sorry for the interruption.
And this is like inside function, and then I don't know. This takes, let's say the f pointer comes in as a parameter. Right. And then we're gonna return a like pointer to bar, like that. And then so we could say return f:b like this. And so what happens is that if this pointer is a null pointer, it doesn't segfault, it just returns a null pointer to bar.
Right.
But if it is not a null pointer, then
Yeah.
it gets the address of B here and it returns that.
So it tests for null and then adds the offset to B if it's null or not.
Right. So if
Yeah.
f pointer is null, then it returns null pointer. If f pointer is not null, then it returns a pointer to this field inside that object that we're pointing to.
Yeah. Yeah.
That's
You have
the
lifetime
idea.
management issues as soon as you start handing out pointers to interiors of other objects. That's a different question altogether.
Sorry?
So it's basically a navigation operator, but it doesn't return the value, but it returns a reference to the value.
Yeah.
Pointer.
All right. Yeah, pointer.
No,
Okay, understood. All right.
my comment was merely lifetime management. You have a foo object with a bar, you hand out a pointer to the bar, then you delete the foo object. And
Well, this takes a pointer to a foo. It doesn't take a foo.
yes, so you got a pointer to a foo. You then call this function and you squirrel away a pointer to bar some other place. Then you delete the foo object. Now you have a stale pointer to bar.
Oh, that's any C++ like language has that problem.
That's what I'm saying. You have more than usual. So in the land of Java, you can't hand out interior pointers so that when all the foo pointers disappear, there are no bar pointers inside of a foo because that's not allowed. And then you can throw the foo away and reclaim the storage. Separately,
Uh,
have a lifetime management of foos, and you know when your foo last use of foo goes away, you can delete the foo and reclaim the storage life goes on. But if you hand out interior pointers, then the lifetime of foo includes the lifetime of the interior pointers. And that makes a harder problem to solve because it's not a foo type thing that you're tracking the life of. You have a bar that is
So there,
inside the foo, as
well,
opposed to other
it
bars.
doesn't do garbage collection, so it doesn't really have the same.
No, if you're using garbage collection, this design pattern is more difficult to write a collector for.
Yeah, it doesn't use garbage collection though.
Okay,
So
and if you don't use garbage collection, it still makes it more difficult to track if your language provides tracking support. If you're not doing a rusty thing where you're doing lifetimes of stuff.
no, it's not like Rust. It's more like C++.
Okay, so you have to malloc and free manually, which then it doesn't matter. It's the same story as C and C++. Yeah.
Essentially, yeah, it's not different than C++. It's using like RAII and manual memory management.
Right. Yeah, so there's a lot of the new languages are doing things with memory management to help people track those lifetimes, which get complicated and difficult to track. So language support makes sense. But you don't, it's not a thing.
Yeah, I specifically didn't want to do that because I feel like it doesn't make programming easier in many cases.
Yeah, I
And
don't know. Rust has this reputation of being kind of a bitch to learn how to use the thing, and you're fighting the borrow checker all the time. So maybe, I don't know. I don't have a good answer there.
yeah,
I don't fight it, but I have so many other complaints.
Okay. Certainly, people who try to do C of nodes, which does editing of the node structure.
Ryan, your feedback
Rust.
is really bad now.
Man, I need to do something about the. I need this headset or something.
Yeah, probably headset switching what there. Yeah, just people doing Rust for Sea of Nodes had all kind of complaints about lifetime management. They commonly then just gave it up and said, I don't have pointers. I have indices into an array, an arena of nodes. And I thought you lost the usefulness of having a pointer in the first place. Seemed like a stiff cost to pay for tracking lifetimes. So I don't know. I think the like, industry as a whole is still looking for a good way to do memory management, sort of outside of GC, deterministic memory management.
I would love to, but I can't. Like, I mean, I can, but
It's
I
a hard
can't.
problem. There's no doubt about it.
Well, it's mostly bills is my problem.
Yeah, well, that's a lot of folks' problems. So Mojo, in fact, says no aliasing to things. Parameters get passed into a function. There's no aliasing allowed on them. And then they can
I mean,
tell.
sort of, unless you malloc a raw pointer.
Say it again. Aaron, you were saying something? All right, I'm going to kill the share for a second here. We lost.
Okay.
I was saying
There's
Mojo has a lot of safety for its own stuff, but it also lets you just make instances of
Oh,
unsafe stuff.
yeah, but so does Rust. I'm not talking about the unsafe piece.
There is
Yes.
this interesting blog post on group borrowing, zero cost memory safety with fewer restrictions, which looks considerably safer to use, easier to use than Rust, but also offers memory safety. And the groups are a little bit like arenas, although the blog poster didn't want to use the word arena because arenas mean very different things for many different people.
Oh,
But if you look
yeah,
at
it
the
works.
code, it's actually pretty decent.
Okay.
It's much easier to write than Rust, I think.
I should read this. This is a guy that works at Modular.
Oh yeah.
I try reading his stuff, but he writes so much, and then I just can't go through it all. Like, I'm not sure. I guess what's that word? Resonates. His writing style doesn't resonate, and there's just so much of it that I just
Oh,
can't focus.
it's big. I have to go read it offline. Is this the Veil? This came from the history of the Veil
Yeah,
language.
yeah.
All right. I'll have to look at it later. That looks
I
interesting.
think when I look at it, the main point was that he doesn't track the object's lifetime per se, but a specific areas. So do you take a pointer from them? Do you are you allowed to read or write from them, and you'll be able to better optimize that. But the key thing is the memory area, mm, so to speak.
The memory what?
Memory area. So a specific block of memory, if you
It's
will,
like
specific
arena, but he
arena.
goes
Yeah,
as
yeah.
a
You can
group.
say it arena. You can say
Yeah.
arena. Yeah.
So I'm actually, I don't know, like I'm personally not a big fan of the whole like memory safety language integration thing because I personally found that if you use C++ containers and RAI together, you can eliminate the vast majority of these situations with design patterns. And in the situation that you can't, I found that I would be using unsafe in the other languages anyway. So I
How
don't
do you deal with the lifetime tracking? If you
you use the containers, right? So if I
mm,
put something in a container,
I think oh, he's just not speaking. Um, so my two comments is when I saw people do Swift and Rust for the Billion Row Challenge and Eclipse CSV Challenge,
Hmm.
and I saw that it's slower than some of the entries in Java, and I think I saw some C Sharp and JavaScript. But anyways, if they were slower, then I'm like, what's the point of even using it? Just use the Java or whatever garbage collector language you like, because most people don't measure, so it doesn't even matter most of the time.
The thing with Java being fast is that the guys kind of
okay.
go to
I
the
know they
middle.
went really into it.
They
Can
can go in right. They can really, but you could do the same thing in another language too.
can you hear me?
Just for me, at least, the GC makes it so much easier to get the basic ship right and running that you get time to do all these go down to the metal and do, whatever software, SIMD and a register kind of things that got those the last 2x. Um, you could have done that in C code, except that you had to get the memory management right. But for those problems, the memory management wouldn't be so huge. Hey, yeah, Ryan, say something then.
Yeah, okay, sorry. I had got a headset, but I had apparently the output of the sound was going to the headset.
Okay, wait. You got really soft. You started strong and you went really soft.
Can you hear me?
Yeah.
Can you hear me now?
You're fading away.
Okay, it's still broken. Hang on a moment.
Round two, fixing your audio.
Yeah, so I kind of just don't like languages that enforce memory safety if it's not garbage collected because they tend to not be any faster than garbage collection. So if you're going to spend twice the time writing code just to avoid the GC,
Just do the GC.
it sounds like you could just spend that time just optimizing.
Yeah.
Yeah.
Unless you're doing hard real-time work. I think
And then you gotta choose C++ anyways, which is gonna not be nice. Oh, and the other comment was I don't use C++ containers. I use my own. And two reasons I do that is I don't like how C++ containers you can automatically, if you assign a container to another container, it'll just make a copy. And I don't want to do that by accident. So that's one reason why I use my containers. My other reason is because I can include my entire standard library, and it takes like maybe 200 milliseconds to include, and like in a blank file. And if I include a bunch of standard C++ stuff, it takes like about a second, maybe a second and a half. And it's just like I rather get my better containers
the
to
C++
my style
standard
than
library is vast beyond belief.
pardon.
The C++ standard library is vast beyond belief.
They support so much, and a lot of it I intentionally don't want to use, like the copying.
Okay. Can you guys hear me now?
Yeah.
Yes, there's a
Okay.
lot of gain, but it's not like loud. It's just we can hear that there's gain.
Yeah.
Okay.
For me, it's
Yeah.
very loud.
So I switched to my headset, but it was still using the MacBook microphone for some reason.
Right. Yeah.
So I walked away, and that's why it faded off because I was trying to walk while talking on my headset.
Yeah.
Anyway, so yeah, I've not been a big fan of the like memory management stuff because I found that like containers and like most of the time with containers and RAI, I don't have memory errors. And in the sort of the situations where that approach is not possible, I found that like I would be using unsafe in the other languages in the equivalent circumstance anyway. So like I don't know, it doesn't seem like it's
But
that useful to
there
me.
are actually plenty of memory safety errors if you stick exclusively to modern C++. If you use containers like standard vector is a pretty popular container. It suffers from iterator invalidation issue in that if you push back something to that container, all of your iterators are invalidated. Rust solves that problem, and it does at compile time show you the error that if you have pushed something back, that container was borrowed, you had a mutable borrow, and then you have another reference to it that is mutable, and you cannot have because that violates the law of exclusivity. So that's one problem in modern C++ that Rust solves. Another problem is if you use string view. String view is a reference type. This
Right.
reference may be dangling. So what I'm saying, if you stick only to modern C++, if you just follow the best practices, you are still going to have memory safety issues that Rust can solve without using unsafe.
Well,
Matt,
that's
I
true.
go ahead.
I was gonna
Hey,
say,
Levo go first.
Who?
Levo go.
Okay, Matt, I was just wondering, I haven't gone around to reading the standard library in C++ 26. Do you know if the hardening and all that stuff is gonna
Oh
put
yeah,
the checks in the iterators for that?
I think the hardening is actually going to do a lot of good. The Apple actually has done even decent amount of work with not that big of a performance overhead, but there is going to be some performance overhead. Although
Is
the
that
mode
20?
that is, although they say that the mode that you are supposed to run in production maybe just a single digit percent, even 1% or less, but that depends. Benchmarking those things is hard, so it's gonna depend on the workloads.
Is any of that going to be in a standard 26 or 29, or is
There
that
is
just going to be
some
prototype?
kind of hardening that goes into the standard, but it's still, in my opinion, it's gonna boil down to how well is it implemented. So I have been watching this implementation in the LLVM standard library libc++. That's the one I'm
Okay.
referring to.
So yeah, I do think that's good, but I guess one of the things that I've kind of, I guess, opposed that sort of like borrow checker is if I'm using Rust, right, I'm giving up a lot of things in C++. I'm giving up, template programming, and a whole bunch of other stuff that just Rust doesn't have. So I don't know. It doesn't seem worth it.
I just wouldn't conflate memory safety with Rust borrow checker. I think we are in the very early days of automatic memory management. In my opinion, as a research and industry, we have devoted too many decades on automatic memory management being garbage collection, and in my opinion, we should have started borrow checker right there in 1959 when instead Lisp started garbage collection in 1959, and now we would have 7 decades of experience.
Um,
And after 7 decades of experience and engineering investment, it would probably be much better than it is now. So Rust
I
right
mean,
now is where Lisp was in 1959.
Yeah.
This is
yeah, but I
how
mean
early we
that
are.
All right. Come
that's
back
the
in
failure
2090 and we'll check in.
of the manual memory management people, not a failure of the automatic management memory management people,
I think
right?
it's
Also,
a resource allocation problem. We have spent too much time on one particular style of automatic memory management, and
Yeah, but
there's many different styles.
the people who were interested in that made it work. On
Yeah.
the other hand, the manual memory management people, they spent 50 years trying to
Oh, I'm talking about
write write
I'm not talking about manual. I'm talking about automatic. I consider Rust borrow checker to be
yeah,
automatic memory management. That the
yeah,
compile takes the
that's
settings
I
for
mean
you.
the people who should have focused on that, focused on making on writing a safe C and C++ code with linters and Walgrind and stuff. So
Yeah.
I
I
just think there
mean,
was not enough work on that. I mean, Cyclone was a pretty late work, and Cyclone is what inspired Rust to a large extent.
I'm actually like kind of on the opposite side of like, yes, what's wrong with, thread and memory sanitizer? Because like that has solved like almost all problems that I've encountered with memory safety. I've been able to identify with those tools and just design patterns in C++. So it's very rare for me to have a memory safety error when I'm
I'll tell you
programming C++.
what, Hotspot was full of them, and every memory checking tool on the planet would fail to on Hotspot generate it on Hotspot code. They just wouldn't work.
Yeah,
Catching
C++.
exceptions is a normal course of events. I think Valgrind, like 20 years later, Valgrind will work on Hotspot with a lot of dedicated PhD students making it go.
And very few people use memory sanitizer in practice because you have to rebuild your entire world, including your standard libraries, to use memory sanitizer. So yes, I'm aware there is an algorithm, there's argument that sanitizers help. It's just that what I look at what people use in the industry, very few people use memory sanitizer. Address sanitizer, yes, and that's extremely helpful. It's still dynamic analysis, but I almost never met anyone using memory sanitizer.
I used it very little, but I did use it. I mostly used it for Bolin because because I didn't need any third party. I didn't have any dependencies, so it can just use the memory sanitizer. But for Bold, uh, since I use SDL and other things that allocates, I just couldn't. So
Quick,
Brian, you said something you broke off.
I was gonna say that the language I'm working on also has a similar I like it's trying to solve that problem as well. Where so my solution for this, right, is you're talking about how like other libraries you have all these dependencies and they don't compile. My solution is like all the compilation options happen at the unit where the program as a whole is being compiled, and like individual modules or dependencies can't set compilation options. Like they can only provide source code. They can't say, oh, I want to be position independent or this or that. Like modules don't have the ability to set those options. That gets set at the whole program compilation level.
I'm just curious because there's definitely people here that use Rust as their day job. Do they want to talk about the border checker?
I don't know if anyone's online right now who uses Rust as a day job. There are people in the group.
Okay, I guess never mind. But
Yeah.
I hear that a couple of them just feel like they're fighting it all the time, and my issue was never that. But I can imagine that being annoying when you have to change a signature, and then it's like turtles all the way down. You have to like change it everywhere.
Yeah, I haven't coded Rust in anger. I've
Okay,
heard similar
let's.
things.
I want to
It's
Simon's
almost a similar
update.
problem to not having enough type inference, where you change a thing in one place and suddenly you have to change it in 40 places because all of a sudden you were passing the immutable thing around and now you're passing the mutable thing because you need it 7 layers deep. Like almost letting Henry Milner propagate a bunch of these things would solve a lot of the problems in Rust's spiral checking anyway.
I keep wondering if that would be true. I know
Yeah.
that Henley Miller has this fabulous ability to do things, and at the same time, when it comes up with an error, it fabulously has obtusified where the error comes from.
But
And so,
because
what happened?
my thoughts are because you don't put syntax on it, he's free to change things, and it turns out that it maybe changes in such a way that you are not intending too often. So you have to have up some balance, at least to me. That's my
Well, you
that's
should
my
be able
stance.
to add annotations to fork,
Yes,
at least.
yeah. You have to harden the guarantees that you
Yeah,
want and to compiler to honor them.
right.
Because if you leave all for inference, it will give you the flexibility to change all the propagating changes in order to make the program work, but it may not be that you intended that.
Yeah.
So one of the issues I hear people in C++ talk about is if they don't like to make parameters constant because if they need it to not be constants anymore, they have to change a lot of places, and then headers will recompile everything and all that. I was thinking about that recently, and I was thinking about maybe I should get rid of the mute. In my language, you're supposed to call mute on every parameter. Like on the call site, you put in mute for parameters that can mutate. But now I'm thinking maybe I should have like a strict mode and a not like a relaxed mode where you don't have to do that, but in the strict mode you have to do that, or maybe make it on a per file basis. I was just thinking about that recently, but
You're talking about I have some volume of code and I want to make a change, and there's some default arguments going to change on me, and now I have to go touch everybody. And do I want to not be
yeah.
verbose? Is
So
there a way to shortcut the verbosity?
yeah, my language was going to be even worse than like C++ because not only would you have to change all the headers to remove the const, but then at the call sites you have to like add in mute. So I was thinking maybe I should not force the mute part and then
Yeah, at
just.
the call
But I
site.
really like that feature of like having like all the parameters marked as mutable because then you're not going to have every single parameter mutable for no reason, and it will be less confusing. But
I'm all
yeah,
about
I
less
don't know.
syntax.
Yeah, so do I. Like if you look at my language, you see this minimum syntax. I mean, yeah, there's minimum minimal keywords, but
So yeah, I've thought about that as well, where I'm like, okay, what if a function call like all arguments are const by default unless you say that they're mutable? My approach hasn't been making the arguments const. It has been like if you don't make the argument mutable when you pass it, then it would become a like it would just be converted to a const reference before the function call like picks a function from the overload set. But yeah, I don't know if I've kind of weighed the pros and cons, and I don't have a good answer because like it makes a lot of things a lot more verbose for sure.
Until you have a large corpus of code that you're writing in anger on, you kind of don't know about all these sort of, I want to say, fine grain how it feels to code. you have to write a bunch of it, and you have to be trying to solve some other problem. And then the constant writing of the mute keyword or not is in your face or it's not.
Yeah.
I think it's one of these things that sort of, I'm guessing, you're guessing what the typical situation, the typical programmer does. Till you sit down and become that programmer, go hack the
Oh,
code, not trying to sort
oh,
the
New
language, not
plan,
trying to
all
use,
values, never mute anything.
yeah, just trying
yeah,
to get something
yeah,
done.
yeah.
Do I have to
Looking,
go
looking,
type extra shit?
mm, looking at a large code base is like one or two millions, maybe
Yeah.
in the 800 millions line.
Oh,
Mutability is never a good thing. So nobody
okay. Who
wants to
said
touch it
800
because
million lines?
no, no 100 millions, a million lines.
Yeah, million
So
lines I've
a
seen.
million
That's
lines,
plenty
yeah,
big.
yeah. So nobody wants to touch it because you do
Yeah.
not understand it.
Yeah.
So
I have a subject change if you guys are done with this topic.
Oh,
I so
I
so
had a
let's
question from Matt about,
and maybe we can hear Simon's update on the enums on the unions.
It's not that urgent. If you have a good discussion, I will happily yield.
I don't know.
all right, I'm
Yeah.
going to do my thing because I'm loud
Okay.
and you guys are being really soft.
Okay.
So LLVM has this thing called a logical result. It's just a wrapper over a bool with some functions to say success or fail and create and assign and return whatever. And it's being used at, modular here in plenty of places. And the common case is to say I'm returning a logical result from a function of some sort of success or fail, and the next guy just tests it. If success, do this, or if fail, do that, or whatever. And looking at where the time goes and profiling things, it appears to me that logical result does not get optimized down to a bool in the vast majority of cases. And that by yanking it for a bool, I got a very measurable, very clearly obvious speed up on hot paths in the compiler. Um, what's going on here? If I have a struct, I return a struct, I make a struct, it's stack allocated, and returning a struct, it's a bool. The caller accepts the bool, accepts the struct, I guess, and tests the bool out of it. Is that LLVM's unable to like wipe that out and just say, oh, just return a bool and test the bool on the other side?
Is
But it's
the
a struct
body
with one field, right? Just the
It's
Boolean
run with
value.
Yeah,
one field.
I know exactly what this is. I actually specifically have been designing Quoxlang to solve. This is like one of the ABI problems with C++ that I wanted to solve. So the problem fundamentally, okay, is it's
can I
fun.
interrupt? Really quick question: is the definition in the header? Like, is all the code in
Yeah.
the header for the?
Yeah, the
Oh,
yes.
oh,
That's a good
weird.
question. I think
I
it's all in the
posted.
header.
I just pasted it. It's a wrapper over bool. I just posted
Yeah.
this.
So the problem that's actually happening here, I call this trivial relocatability. And the problem is that a C++ class by default is not trivially relocatable. And so what I've done in my language is I'm adding a keyword, you stick in your class, you say I'm trivially relocatable, and then it will behave like a bool does because a bool is trivially relocatable. But like fundamentally, the problem here is that a constructor can take the address of itself, which means that from an ABI standpoint, anything that's a class, the constructor is called by the callee, and the destructor is called by the callee as well. Whereas when I pass a trivially relocatable thing like a
Okay.
bool, these get called in the caller, or sorry,
You're saying that
I did it backwards. Okay, so the caller calls the constructor, and the caller calls the destructor, whereas the callee is just examining something that has usually been passed as a pointer, not as a value. So in my ABI, I'm saying, okay, if
well,
a
wait, this
high,
not I don't want to go down how to solve it because I'm trying to solve it for performance here. And any language worth of salt can solve this one way or another. But I'm trying to figure out what the failure mode is. And what you said was because the constructor might take the address of itself, the ABI is restricted in saying I can't convert the struct to a bool. I must treat it as a struct.
Well, it's not really that it must treat it as a struct. It's that the caller retains the memory for
Right.
the object, whereas if
Okay,
I
so as
pass
soon as
the
you said
bool,
memory, I have a bool. Why is there memory involved? Okay, because it's a struct. The caller made a slot on the stack for the bool, passes the pointer as a hidden argument, I'm guessing. The called function fills in the bool and returns whatever it returns, it doesn't matter. And then the callee then goes and sucks the bool up out of the stack slot again and tests it.
right? So this can fail to optimize. So like in theory, if the you know if that's inlined and the compiler can see, oh, I see every write and every read, and I can see where everything went. In
Yeah,
theory, it can like say, okay, I don't
yeah,
actually need to make this stack allocation, and I can see that no
right.
other function could possibly in any way, shape, or form modify this bool somewhere
Yeah.
else.
Right. But
Then
you've
it
put
can
enough
optimize
legal
it out.
words in that we're done already. The caller is a large function. The callee is a large function. They're not inlining into each other. They're big. The callee starts with if some trivial condition is 95% of the time true, return success. So the callee is heavily filtering for an immediate return. And it's being called millions of times. So he does an inline, it's called millions of times. The only thing the callee does is 95% of the time test a bit and declare victory and get out. So all the overhead is make a struct, yank a struct
Yeah.
off the stack.
So it's a problem that it's just a problem with the ABI for the call that before the optimizer pass happens, that ABI, like the way Quackslang is solving this is that I'm making certain types just trivially relocatable, which guarantees that they get passed as values in
Right.
the ABI,
Yeah.
but C++ doesn't have that. So
It's
even
like I
though,
want a register keyword here that says
I was going to
this
say,
struct
even a
something.
struct that has multiple pieces can be passed in registers if you don't take the
Yeah.
address of it. Like,
Right.
why is this not a struct being passed in registers as part of the calling
because
convention?
it just doesn't, just the optimization pass didn't catch it. Like there's too much code, some possible way that the address leaked out and it can't prove that, you aren't doing something funky with the bool at some point, or, there's all sorts of reasons why the
If I
compiler might not
recall
be.
correctly, that's related to the reason that the unique pointer is not an zero overhead abstraction, right? Because you have a similar issue when you pass a this unique pointer as an argument, that it's actually gonna introduce one other layer of indirection.
This is like a Godbolt question.
No, I think unique pointer is the same as doing well, okay, yes. So there is one
So I remembered
extra.
it was the IBI was at blame for this
Yeah,
also.
yeah, okay. Yeah, so this is technically, yes, when you pass a unique pointer, there is an extra level of indirection that can be sometimes optimized out and sometimes not, because yes, the caller retains the memory for the unique pointer and you have a pointer to that. It can be optimized mostly away. If the compiler is smart enough to like hoist the value of the unique pointer on the function entry and then write it back
Yeah,
after
yeah.
it
I mean,
makes
if
it.
you're all
I
things
just really badly want to say this, but the LLVM has a remark compile flag, or a Clang does, and it will outputs why something is not inlined. So if you have a file that's not like inlining, you
yeah.
can just pass the remark flag into it. I forget the exact syntax. I'm just like looking
Yeah.
at it now, but it will say why, and it could be a silly reason, but maybe you can figure out why.
Yeah. So in Quackslang, this exact problem, like that unique problem, pointer problem, is going to be optimized out. Like because in this language, the callee is the destructor runner rather than the caller, so it wouldn't have that problem. But
So like here, we'll get something like this for foo and bar. Whatever,
yeah,
true or success or something.
so this entire problem is just in C++, the destructor and constructor both execute in the caller. And
Oh, the
in
constructor has to execute. Yeah, it does. Oh, I see. And now the callee doesn't know anything about the lifetime management of the caller. because
Right.
you're turning it. Oh, that makes more sense. Oh shit.
Well, it runs the destructor after it the function call ends,
Yeah,
right?
yeah.
That's a caller that does that. So
Okay,
if
so
you
let me go inline what now my understanding is now approaching here. The result guy gets constructed here. Bar is called with a hidden address of result. Let's see, I misspelled on purpose. He has a hidden extra argument here, which he doesn't know anything about. So when he returns true here, he actually comes through and says, return void, but he's like he's updating the damn thing in place. He's doing a move.
It's not usually a move, it usually just directly writes when you construct it.
Okay.
What,
Well,
what,
here.
How is that different than any return value that's a struct?
It's not. It's why does the fact of separate compilation deny the obvious compiler optimization? And it's the fact that foo and bar are in different compilation units. Um, and they're passing this thing back and forth, but bar doesn't know where result came from. So he has to assume that bad things have happened to result. So he has to actually do the write to memory and has to take the pointer to it. And foo doesn't know what result bar is going to do with the thing other than return it. And in theory, bar could do horrific things to result. So he has to make a struct somewhere and pass a pointer to it. So there's no dodging the obvious, just put the fucking bool in a register. It has to be in memory.
It doesn't have to be. I mean, if the compiler analyzes it, they can simply
No, right.
say,
So it's separate compilation. So foo and bar are separate compilations. So the compiler has no chance to analyze between the two. He has to pick up
well,
the third thing, which is the logical result header file, but they both suck in the header file.
well, the
And
ABI is really the problem. The ABI says,
yeah,
okay, you get a pointer and then you do something to it, and then that's the ABI. It has nothing to do with whether or not foo does something terrible with it or not. Because like you can know that okay, it's
yeah.
going to be destroyed, but you're still not the one calling the destructor as the callee. The destructor is called by the caller. So
No.
because of
Right.
that,
If the compiler were sufficiently smart, it has nothing to do. This is what I'm saying. Sufficiently smart. So he steps around the ABI and says, "I know I'm going to get a bool back, and the thing I'm calling knows that he's going to return a bool. So I don't need to hand him a pointer to a result, to a logical result, and he doesn't need to set a logical result. He's just going to hand me the damn thing and register."
Maybe sufficiently smart LTO,
Yeah.
but
Right. The link time. Yes.
yeah.
Okay. I wanted to know, and now I have a good answer, and the effect is actually significantly faster. I'm going to probably walk through the code base that I'm looking at and look at a bunch of other places where logical results being used and yank it.
yeah,
Um,
Wouldn't
and
wouldn't inline save the day
well,
here?
the
Hmm.
problem here is I have to inline the header, the leading part of bar into foo. So bar is big, so I don't want to inline it because it's a giant thing.
Hmm.
And it's called from dozens and dozens of places.
And
So, I don't want to inline this giant thing in a dozen places.
while logical result has to remain an object here because of
Okay.
with the addresses, but
Well, the declaration is it's an object.
mhm,
Bar is being called from many places. So all the callers of bar all agree that they will pass bar a pointer to a result that they've personally allocated.
mhm,
That's the
okay,
ampersand result coming in.
okay.
What I
yep.
would like to have said was that all the callers of bar who had all these different compilation units, all the callers of bar, all agree that bar should really just return me a Boolean on register and
Yeah.
skip the whole logical result thing.
Yeah. While logical result isn't, let's say, type alias, or the other thing should be
Go
baked
ask LLVM.
type.
This came straight. This is literally the LLVM code I'm looking at
Yeah,
work.
yeah. So this should be, if it's a value, let's say a value type, it should the semantic should be always erasable to a Boolean to
Uh,
what it represents.
right. Sort of trying to push something upstream to LLVM.
Hmm.
I'm like, don't use this guy or replace him with a macro that has
Yeah,
pretty success and failures or something.
yeah. Why not?
I mean, you do know a guy in that community.
I do. The surprise to me was yesterday coming around and like, this matters. And the answer was yes, it does.
And
Brazilian here. This is roughly 1 million. I'm sorry, actually here, this is called 1 million times and has a roughly a 95% cutout on cheap test. There's a second test that follows it that cuts another 95% out, which I'm not showing, but the general theory here is almost always out of the million times, I just want to return a bool, a success bool, and get away. I want to return true and walk away. And instead, I'm paying some overhead that's measurable on a large variety of benchmarks. Some of them are up by integer factors of slow. Like this one change of getting rid of logical result on bar to a bool was good for 2.5x on at least one benchmark, and
wow,
significant fractions across the corpus of a bunch of them.
yeah,
A few
I think
hundred.
I've tripped over something similar to that once, where I had a function that took a range object that had a start pointer and a stop pointer, and we
Yeah,
switched it to passing in just two fields that
just
were
the two
both
ends.
pointers and got a significant speed up over the struct of two pointers.
Yeah. I mean, if inlining was necessary and was
That
happening,
surprised
I
me.
think the struct for the result would go away. But if it didn't inline because you're not doing link time optimization, then yeah, you pay the price. Okay,
one day
my
we'll.
mystery's been solved.
I actually found a talk that I'm about to link. It's about the unique pointer example. It's going to be 17 minutes, 30-minute mark in the CPPCon 2019 talk by Chandler Caruth. There are no zero-cost abstractions.
Oh, I think I've seen parts
There,
of
there
it.
will be. I'm gonna make this zero cost.
Excellent.
That was like one of the main design points of my language. It was like,
Yeah.
okay, I've
That was your
identified
pain
these
point. You're
APIs.
gonna fix it.
Of
I
course,
am.
strictly speaking, there is your cost as an implementer to make it work. But I get your point.
Yes, yes. All right.
I mean,
Hey,
type alias is pretty cheap.
See chat. Okay, that's
did you see the remark comments I put at the bottom?
I saw the no zero cost remarks in chat. You're talking about over here. Yeah, I saw the R pass. This is what you're talking about?
Yeah, yeah.
Yeah. I mean, I have never seen this flag. I can go screw with it. I will almost surely, in this case, I'll almost surely say, well, foo is in file X and I compiled it alone, and bar is in compiled Y and I compiled it alone. So, no inlining happened.
Yeah, I think I only ever heard of that flag mentioned here and maybe one other Discord, but that's back when I had
Yeah,
Discord.
I know.
Yeah.
It's easy enough, I think. I have to dive into the guts of Bazel, but it's easy enough to add the flag and just see if it prints something exciting on me that I'm not aware of. When I personally write code that has this kind of a pattern, if cheap test, and then do something cheap and get out, um, in order to encourage inlining, I will frequently go into the include file and say up through here is included, so it's inline. And then the remaining 1,000 lines go into the bar under impl, where that's implementation. Some other thing. I break this into two functions. The first of which is going to get inlined in case the compiler doesn't inline for me. You kind of force the issue.
I don't like Pimple.
Yeah, well, fine,
Lots of writing.
your own name. It's the other half after you got past the guard checks. Like bar is I'm resolving types, and it's resolving types that haven't resolved yet or something. There is a version that says, "Oh, this is type has been resolved. Get done." And the other one is it has not been resolved. Oh, start doing all these horrible things. But people call it
I've
willy-nilly.
seen a lot of stuff in
Don't
this
think about it.
pattern of do thing calls do thing unchecked.
Yeah, exactly. Yes. Yeah, unchecked. Do thing and do thing unchecked. However you want to phrase it. But you can force the inlining of the hot case in case the compiler doesn't do it. C2 actually has this kind of a pattern as a quick cutout. He will inspect the first few bytes of bytecodes of the front of any method he's not going to inline and see if it has a fast, cheap cutout test that he can inline. the very common in Java, the cheap bit test is a null pointer. If argument is null, return null. Else, horrible thing. So go look at the first few bytecodes. They say load something, test for a constant, exit, inline that section.
All right. I have the subject change if you guys are ready.
By the way, Cliff, try recompiling with LTO, just out of curiosity. I do know that
Yeah,
some
I'm not certain that I can live that long.
there's that. But Clang compiler does get faster when compiled with LTO and PGO. That's and like 10% to 15%. It's actually not a small number.
Not a small number. Okay.
Really? I never
Yeah.
had that work for me.
But you have to combine both LTO and PGO. Funny enough, it was actually GCC guys that did the comparison. There was actually a talk by a GCC developer that was doing a thorough comparison of all of the optimization of Clang and GCC, and that was one of the findings that combining LTO with PGO on
Yeah.
Clang LLVM does help with large executables.
I would imagine so. I mean, this is the domain that Hotspot lives in all the time. They're all fucking million line programs,
But
and they have
exactly,
profile guided.
and it does show in large executables. So I mean, like Clang, LLVM, or Chrome, that kind. So maybe that's why you didn't see it, Levo, because you probably weren't compiling something of that size.
Right.
Well, yeah, also PGO did not work for me for whatever reason, but I only ever tried that on Bolin.
Which if you do PGO, don't you have to then run a profile guided run?
Yeah, it just didn't work.
Yeah, you have
It
to
got
have
it became
good
slower.
Go ahead.
No, that's it. It just when I ran it on Bolin, my compiler, it just and then I tried LTO and whatever. It made the program slower. So I guess I
You should,
either did something wrong or there's a bug or I have no
yeah.
idea.
You may need to run this on representative workloads. In particular, do not train your compiler on the test cases because this is exactly what would result in slowdown. Because test cases for compilers are usually extremely unusual code.
Yeah.
So you would exactly train the PGO to pessimize your compiler if you were to do that.
Yeah.
What I did was I ran it on the test case and then I measured it on the same test case, like nothing different, and it got slower.
All
Then
right.
it's actually impressive, yeah, if it didn't get slower because test cases are pretty much the edge cases that compilers almost never deal with.
So I ran my particular case on the CI tests, and but there's a large fraction of them that I just threw out because they threw an error on purpose and exited, and that's exactly not the case I want to optimize for. Yeah.
I was wondering, do companies not sponsor GCC because there's like no GCC foundation? They do GNU,
Oh,
which is like all sorts of things.
GCC does get indirect sponsoring in that there are compiler developers working at companies that contribute to GCC as part of their day job.
Well, I know people will contribute. People and companies will contribute code, but do they ever like contribute give funds?
I think there's been some funding for G4tran.
Google funds both GCC and LLVM.
Okay,
Okay.
because I
Oh,
just assumed they didn't because there's only a GNU Foundation and not a GCC Foundation.
no, it's GNU covers the GCC. It's the umbrella, right?
I don't know if
I was
it
under
can
the
be.
impression it was the GNU C compiler. No?
Yeah.
I think GNU is just like all sorts of open source
Oh,
stuff.
sovereign tech. What?
Uppercase GCC is the collection, lowercase GCC is the compiler.
Yeah.
So
It's
the
not like
German
a big.
government is investing in Fortran.
Yeah, I don't care too much. I
Fine.
was just thinking about it.
I'm scared as to what Fortran code they're running that they need more improvements on, but fine.
The Department of Energy weather simulations are almost all Fortran code.
As soon as you say Department of Energy, I'm like, and nuclear bomb fallout codes are almost all entirely in Fortran.
I assume that the Fortran code that did the nuclear weapon simulations is still running somewhere.
Yeah, probably. Yeah. Fine. All right. Done.
I wonder how much Fortran code written by Grace Hopper is still running in our Department of Defense.
COBOL or Fortran. She might have written Fortran. There was a 10 or 20-year span between them, right? Well, maybe only 10.
Lots of national labs in general, I think.
Okay,
It's
fine.
it's actually interesting that Fortran, I think, could have been really taking the role of C++ now in machine learning. Like when you see those stacks built on Python as the glue code that underneath called C++,
Right.
one would think that Fortran could have been in this spot, and Fortran is a pretty good language to optimize for as far as numerics are concerned. But I think they were late with the standardization of general purpose programming language features. Like Fortran is great at numerics, but it really sucks at text processing. And at the end of the day, if you want to plug yourself into some machine learning, or even in the ancient days where people were calling this data science, there used to be a profession called data science, and those
Yeah.
people would read files from the internet, like even CSV. Fortran really sucks, or at least used to suck for processing strings. And I think it's because of that it didn't have this glue parts to plug itself in as a general purpose programming language. It didn't get
Right.
nearly as popular as it could have.
Yeah, I'm
Yeah.
curious if people are going to decide that CUDA is too hard to write and Fortran's going to become popular in the AI community again.
Yeah, well, the Mojo team is hoping to make it Mojo and not Fortran, but that's a different
Yeah.
thing. All right.
There's like a ton of competitors or up and coming competitors to Cuda. I mean, even if you consider Triton, which is like this
A lot of
domain-specific
them.
Pythonish language for writing kernels, it has this interesting programming model when you basically program as an entire tile instead of the Cuda when you have this flat index block index, which is, I think it's kind of interesting. There's a lot of going on right now in
I
the Python ecosystem.
I find it amusing that both CUDA, Apple's Metal API, and also AMD HIP all use C++ as their GPU shader language.
Yeah,
I
could
I,
could
I
have been
mean
Fortran.
I mean if your language adoption depends on people voluntarily learning your new language, then it's a failed endeavor, which
Yeah.
because it like never happened. It's like it's not
All
going
right.
to
All right. I'm
happen.
going to be done so I can go do other things with my life. We ended here on a bang, I think. It's all good. And see people next week.
All right, see ya.
Right. Bye-bye.
Have a good weekend.
Bye.